Hi students, let us discuss some of the thermodynamic state functions or state variables in this class. Thermodynamic state functions are state variables. What is a state function? A state function or a state variable is dependent on the state of the system or condition of the system. So depends, state variable or state function depends on the state of the system, or we can say that condition of the system, condition of the system. Clear? A state function, the term, you can observe the term state function, which defines the state or condition of the system. Observe carefully that a state function does not require the path with which it has come. Means path is not necessary for it. It only purely dependent on the condition. Condition means initial condition and final condition. Clear? Let us see clearly about these state functions. State function changes from one state to another state. One state to the another state. Example, observe. Let us say that this is one system. I am defining the system with some variable, state variable, its own state variables. Let us say that it is having a pressure, that is the P1 is 1 atmosphere, and temperature T1 is some 27 degrees centigrade. Okay, and volume is, let us say that 20 liters. Okay, this is the initial condition or initial state of the system. This is initial condition or initial state of the system. Initial state or initial condition. Initial condition of the system. Now, this system having this particular P1 pressure, T1 temperature, and V1 volume is changed to another state, another system, that is the same system, another state, that is P2 pressure. Let us say 1 atmosphere to the 2 atmosphere, change it. Temperature T1 27 degrees centigrade to the T2, let us say 35 degrees centigrade. Volume V1 20 liters to the, let us say that V2 volume 30 liters. Okay, that means one sort of the condition, sort of the state has been changed to the another condition. This is known as final state. Or condition of the system. That means in particular, the state functions are the state variables dependent upon the initial conditions and the final condition. They do not depend on the path with which they have come. There is no need to describe the path for these. They are purely the condition of that particular state of the system. Is it clear? Right. Let us take some examples. Okay. I quote some examples for the state functions. Here, examples. Number 1, pressure. Okay. From the initial condition, let us say the pressure initial condition is P1 or Pi. Okay. To the final condition, it is Pf. Final pressure, initial pressure. This is initial pressure Pi. Final pressure is Pf. Pf, final. Pi, initial. Final pressure. There is a change in pressure, dP. Final pressure minus initial pressure, Pf minus Pi. That is the initial condition. This is final condition of the system. This is initial and final state. Initial state. Clear? That means the pressure is a state variable or state function which is from the initial to changing to the final. There is a change in pressure is Pf. Change in pressure. Change in pressure is delta P. Pf minus P. Clear? Right. Let us take up another example. Volume. Volume. Okay. The second example, volume. Okay. This is initial volume Vi. For the final state, final volume, there is a change in volume is delta V. Vf, final volume minus initial volume. So purely volume is a state function which depends upon initial state and the final state. The change in volume is Vf minus V. Similarly, temperature. Temperature is a state variable. Initial state temperature Ti, final state temperature is Tf, and there is a change in temperature is dependent upon the Tf minus Ti. Final temperature minus initial temperature. That means temperature is also dependent upon the initial and final to calculate the change in temperature. That means it is a state variable. Nowhere is path is described. No, not necessary to have a path for this state variable. State variable describe only the condition of the state of a system. Understand? So take up much more examples. Okay. I take up the enthalpy. Enthalpy. Enthalpy, which is a enthalpy, okay, which is the state variable, that is initial enthalpy, final enthalpy, change in enthalpy is that is Ef minus Ei. Similarly, entropy also, another state variable I can quote. Entropy depends upon the initial and final. Change in entropy is final entropy minus initial entropy. Another one I quote as the internal energy of the system. Internal energy. Internal energy. Initial internal energy is denoted as U. Initial internal energy is Ui. Final internal energy is Uf. There is a change in internal energy, delta U, which is nothing but Uf minus U1. This is the initial condition and final conditions. The internal energy depends. So Hence, internal energy is a state variable or state function. Similarly, Gibbs free energy. Gibbs free energy. I take up the Gibbs free energy. Gibbs, seventh one I take up. Gibbs, scientist name, Gibbs free energy, which is initial Gibbs energy Gi, final Gibbs energy, free energy is Gf. So change in Gibbs energy, delta G is Gf minus Gi, Gf minus. So Gibbs free energy is also a state variable. So conclusion is that these state variables depend on the initial conditions and the final conditions of the system. Clear? Observe, here I would like to explain by means of a simple graph. I take the pressure versus volume graph. I take the pressure versus volume graph. This is x-axis, origin, y-axis. On the y-axis, pressure in the atmospheres, unit. On the x-axis, volume, V, in the liters. Okay. Let us say this is the graph. So, as the volume is increasing, pressure is decreasing. Pressure is decreasing. This is the point A, point B. Initial point A, final point B. Clear? Now observe here. If I drop here, corresponding to the initial point A, volume, initial volume is VA. Corresponding to the final point B, final volume is VB. That means that the change in volume is dV is final volume corresponding to B, VB. Initial volume corresponding to A, VA. So change in volume depends upon the initial and final state. Similarly, if I take up the pressure case, this is the initial point. Okay, corresponding is PA. This is corresponding is PA pressure. Okay, and final pressure corresponding to the B is PB. So initial point, final point, initial pressure, final pressure. So change in pressure dP is final pressure minus initial pressure. Pressure in this case, in this graph, depends upon the initial and final condition. As the volume is increasing from the A to B, volume is increasing from the A to B, pressure is decreasing, pressure is decreasing. Clear? Okay. Now, when we discuss about the state variables and state function, there are other functions also which are path functions or path variables, path functions. Okay, let me take up the path function or the path dependent functions. Here I quote path functions which dependent on path functions which dependent on the path. The path is necessary for this, whereas in the state functions path is not necessary. How they have come, it doesn't matter anything there. But here in this case, path is necessary. Observe carefully. Let us say that work or heat, these are known as path functions. They depend upon the path from which they have come. Okay? So here these are very, very important parameters, that work and heat are the path functions. Path is very important in calculations of the work and heat. Is it clear? So today I have explained the difference between the state function. They depend on the initial condition and the final conditions. Also today I explained about the path functions, which are work and the heat, which are purely dependent on the path they have come.